Hello everyone, Ken here, back with the third installment of my Data Science Fundamentals series. In this video, I'm talking about data cleaning, why it's important, as well as some of the main techniques for curating your data set so it can be run into a model. Now, in data science, you hear a lot about garbage in, garbage out. If you put poor quality data into a model, you'll get a poor result of that model. So it's really important to set the foundation to understand what makes a good quality data set. How do you take a raw data set and make it into something that is clean enough to get a good output out of? In the first two videos, I talked about data exploration and data manipulation. You can see links to those in the description below. You don't need any of the information there to follow along with this video, but it wouldn't hurt to go back through those just so you're familiar with how I teach and some of the concepts that I use continually. Now, as usual, if you enjoy this content, please hit that like button. And if you'd like to see similar videos to this, please subscribe and turn on notifications so you can know when I publish new material. Alright, so we'll be using the same data set as my previous two videos. This is a car pricing data set from Craigslist.com. There's a link to that in the description below. I got this data set off of Kaggle, so you can go on there, make an account, and download it. I'm going to set my working directory to the folder that has this information. And the first thing that I'm going to do is also create a new file. So I'm going to save this into the same location. We're going to call it data cleaning 2. And now we're ready to get going. So as usual, the first thing that I'm going to do is I'm going to import Pandas and alias it as PD so that we can go forward using that. Next, I'm going to read in the data. So we do PD read CSV. And I like to just copy this name. Saves us a little bit of time. Great. So when you see me highlight it, I press Control Enter on Windows, and that actually runs the command. That's a question I've gotten asked a reasonable amount in some of my past videos. So I believe it's Command Enter on Mac to do that. That lets you just run one portion of your code rather than pressing this button and running the whole file. So now that we've read this in, we can see the data frame in our variable viewer here. So a good practice for me is just to look at the columns. So we've done this before. We can see what all of the features are in our data set. And then we can also do data.describe, where we can see all of the characteristics of the numeric fields in our data set. Now, this data set, I've already looked. It does not have any duplicates, but if I wanted to remove any duplicate data, I would do this. So we're going to remove duplicates, and then we do data.drop duplicates. And we're going to do in place equals true. So that means it's going to use our data set here and drop all the duplicate rows from this one. So if I didn't have the in place equals true, this would initiate a new data set, and I could set it equal to like data set 2, but it wouldn't affect the existing data frame that we have. When we do in place, it affects the existing data frame that we have. So I don't expect, again, there to be any duplicates there. Now, the next thing we do is we check for null values. A little bit of this is review from our data exploration, but this really builds on itself here. So, values, and we're also going to look at the percent of null values that we have. So we can do data.isNull. And so if we just were to run this, we would get in each column, each row, if the value is null or not. And so here we can include the any method, and then we can see for each column if there are any null values at all. And so you can see URL. I believe URL is the primary key of this data set, so there shouldn't be any nulls of that. And then we have city, city URL, and price. So it looks like for a Craigslist car ad, you always have to include a price. That's a feature that they have. All of the other ones appear to be optional. So we can also look at the percent of each of these columns that is null. So we do data, same thing, is null. And since these are trues and falses, when we just do the is null portion, true is equal to 1 in Python and false is equal to 0. So we can do sum, and we can get for each column how many of the characteristics are not null, right? So basically all of the characteristics in the URL are not null. Actually, it sums up how many are null. I apologize. So if we divide this by the total number in each column, so we can do data.shape. So if we look at just data.shape, it gives us how many rows and how many columns, right? So we would want to take the first one, which is the number of rows, and that gives us the percent of each one that is null. So very few null ones in year, but there's a lot of nulls in the size of the car. Maybe that's a bit more of an ambiguous field. Now the first thing I'm going to show you related to nulls is how to remove columns or rows that have over a certain threshold that you wouldn't want. So let's say a column has, like size, over 65% null. We might not want to include that in our data set unless we were saying, hey, you know, this is a meaningful feature if they include size or not, or you change it into a binary or a small categorical variable. A lot of the times, if there's a really high percentage null, you're looking at like 90-95%, you might just not want to include it all, and this is how we would handle that. So we're going to, in this one, remove null columns over a threshold. Right, so we're going to make a threshold, and we're going to say we want less than 60% to be null. Right, so we can take the length of the data frame, which is going to be the same thing as that shape number. It's just a different way to do it. I like to mix it up just so you guys have a bit more variety in how you can issue commands. And we're going to multiply that by 0.6, right? So this threshold looks like that's around 260,000 of these rows should be not null. And so we can now do data.drop NA, and we're going to set the thresh equal to our thresh variable that we had above. And it's important here that we set the axis equal to 1. So in my previous videos, you know that the axis is if we're looking at the columns or we're looking at the rows. So in this one, we want to drop the columns that have a threshold lower than this. And so again, here we did not do, we did not use the in place. So you'll see the data above is not affected at all, right? And we have this data frame that we output. So we can do on this, let's do shape and see if it's different than the one above. Oops. Sorry. So as you can see, we dropped 4 columns because 4 columns were above that null threshold. We can also drop rows with less than a certain threshold as well. So we can do data drop NA thresh, and then since we have 22 columns up here, let's say we want a data frame where all the rows have at least 21 values that are not null. So we can set the thresh equal to 21, axis is equal to 0. So let's give this a go. As you can see, it'll output. Let's do the same thing with shape. And we'd expect to see significantly less in the rows value. Exactly. So this cut our data set by almost 3/4 doing that. We have a couple options. We can either drop nulls or we can impute them. So we can fill the NAs with a different value. So sometimes it would make sense to fill it with 0. So let's say that in a categorical variable, we have a lot of nulls. We can actually make it that we can use that as a feature to say if they didn't respond to this question, that could be meaningful. We can also replace that with the average of all the things in the column or the median of all the things in the column. And this is part of feature engineering that can be fun, that can help you improve your model. So the decisions you make here can have an impact on your model. I usually go through a couple of different versions of this. So I'll look at the mean, the median, we'll look at quartiles, different type of quantiles, etc. So I'm just going to show you here how to replace a numeric variable with the median or average if there's a null in that column. All right, so what we're going to do here is we're going to look at, let's see here, let's rerun this %null here. So I know odometer is a numeric variable, and we can see that from when we ran describe. So if we're looking at that, we can say, okay, I want to replace all of the null values in odometer with something numeric so we can run it through our model. So the way I would go this, null values, is we just do data odometer. Did I spell that right? Find out real quick. I did, great. And then we just do fill NA. So it just will fill all of the null values in that column with data.odometer.median. So I like median. It's a bit more normalized if we have like really crazy values, which we might, and we'll find out a little bit later how to evaluate and look for that. So here now we have, if we did this in place is equal to true, it would fill it in the actual data set. We can do now is null, and then any, and we shouldn't have any null values exactly. So it's perfect, we're false on the null values there. So we can do the same thing. We can put a function in here as median. This median is just the built-in Pandas function. We can also do mean, and we'll get the average imputed in there instead. So that's a great way to replace that data. It's a very common approach to handling null values. So moving on from null values, I think it's always interesting to manage working with some text in your data set. So in this specific data set, we have like a description field. And the description field has a mix of capital letters, lowercase, numeric, etc. And if we want to be able to evaluate that as effectively as possible, we should probably make all of the letters lowercase or uppercase. That means if we want to use a bag of word, if we want to use some of these other techniques, everything is normalized. You can't really get rid of spelling problems, but this is a great way to make your data as similar as possible. So we're going to convert here to all lower or upper. So let's just take a look at data.description. So it's DSC, and we're going to look at the head of that, right? And so that's just going to give us the first 5. So you can see selling, BMW, all of, a good example is we have classic Ford needs a home. That's all capital. That might look different in some of these different algorithms. So we want to just turn all of this into a lowercase set. So what we can do is we can do data.descending we're going to apply a lambda function, which I've talked about in some of my previous videos. This just basically lets us write a really quick function and apply it to the variable. So we do lambda x, and we do x.lower. So that just converts all of the text in x, which is our row, to lowercase. So let's just do the head of this here. Oh, actually that won't work. No, it will. Head. And we can see the same thing is just now converted. Float has no... It looks like so there are some numeric values in here. That's another data pre-processing thing that we'll have to do. I know that there aren't any lower cases in the head of that data frame, so let's just look at the head and apply the same function. Good. So we can see this eliminated all of the upper cases that we were seeing before. We can do the same thing the other direction, where it's going to be lowercase, where we change this to upper. There we go. And it'll change everything again to uppercase. Now, you saw that we had kind of a type error before. That's something that now we can go into and talk about, okay, how do you manage the type errors? So we had some float, it looks like that means that there was a numeric value, just a numeric value here. Going from float to string is pretty easy. Going from going from string to float can provide some more complications. So let's just handle a quick from like float or int to string. So to string. So we can just do data description dot as type string, and it'll return everything as a string. So we shouldn't have the same problem that we did before. Step lower, and that should work. Again, unlike before where we had some of those issues, it now works because it is classified this all as a string. We can see this by doing data.dtype, and it'll show, dtypes. There we go. So data.dtypes, and it'll show the type of all of these things. If it is object, it can be a mix of string and float and int, or some of the different types. So we want to make sure that in a circumstance like this, we set a hard rule about what it is and what it should be. Going the other way, this is a pretty like almost textbook picture perfect example of how you might want to go from string to int or float. So we'll do to float. So we're going to look at data.cylinders. Head. So it looks like we have 4 cylinders, 6 cylinders, 8 cylinders, 6 cylinders again, etc. And we also have some nons in there. If we wanted to understand this differently, a lot of people would say, like, why don't we just use 4, 6, 8? Why don't we actually keep them numeric? And we're going to go through some code about how to actually clean this up and make it just a numeric type. So nothing to do that. Now we're going to go to data.cylinders dtype just for a little background, so we know that it is an object. So that means it can have like a mixed type. We're also going to do data.cylinders.value counts just to see how many are of each different type. So we have other, we have 3, 4, 6, 8, 5, 10, and 12 cylinders. So no 16-cylinder cars in this data set here. I guess they're not selling any Mack trucks or anything. But the next step here is that we're going to replace cylinders with basically a blank space. So we're going to remove cylinders from all of these variables. We're going to data cylinders dot apply. So I like using lambda functions here. So lambda, and then we're going to do lambda x, and then we're going to take, we're going to make sure x is a string. We're going to take that. We're going to replace cylinders. So these are all cylinders. We should probably do, change this to lower, right? Knowing that it's a string. And then we're going to replace cylinders, we're doing lower just to make sure that cylinders are all the same. And we're going to replace that with just a blank, right? Sorry. There we go. And then we want to strip this of any extra. So strip just removes any extra spaces on the outside. So this should clean this up quite a bit. And we want to set this actually equal to this. So this will actually change data cylinders in our data frame here so that it has cylinders removed and it is stripped of any extra spaces. So that was actually pretty quick. Now let's look at data.cylinders value counts and see if it worked for us. Nice. So we still have this other that we have to deal with, and we have a lot of null values. So there's a couple different things that we have to do here. So we can transform other into nons, I believe, by doing this one quick step here. So we can do data.cylinders, and then now we want to use pandas to numeric, and we're going to do data.cylinders, obviously, and there are going to be errors thrown. So ERRS, and they equal, we want to coerce them. So that should make them into the correct data type. So let's try this one more time. We're going to do value counts again. And now we have a good clean data set of all cylinders. So the next thing we would do again would be to fill the null values. So let's look, data.cylinders is null any, and let's compare that to the null values that we had before. Oops, we want to sum them, sorry. Cool. So we were looking at 178,000, which seems to be good because that would include the nons there as well as the other here. So we can now impute them with data.cylinders.fill NA, and then we want to do data.cylinders.mean. And then we'll do in place equals true. So that will fill all of those data frames there. Well, all of that data frame. So now we should see there's no null values. So when you're actually cleaning data, one of the most valuable things you can use is histograms and box plots. So they tell you if there's something basically wrong with your data. So let's look at a box plot first. We'll do data.boxplot, and then we'll look at odometer, right? So let's see here. We should see, okay, so there's a ton of outliers that go above here, and this is LE, so this is to the 7th. So we're looking at, 100,000-ish miles, might be more than that. But usually you want to see a big box because that's where the main bulk of your data is, and then a couple outliers on the top. If we look at price, I think price is extremely skewed as well. We can see that, the box is very small here, and we see a lot of upwards deviation. This is like millions, billions of miles, which is probably unrealistic. Someone probably fat-fingered some things there. So let's focus on understanding what this tells us about the data. That means that there's some error, and we probably want to clean this data set, maybe take a z-score within a certain range rather than using all of the data points, because this error is likely related to someone mistyping something, not something that is actually within the realm of reason. The other thing that we can use is a histogram, and let's do this for odometer. And so this tells you how many data points are within certain ranges. So again, we have very few that are super high, and that's skewing everything to this one bucket here, which is not what we want. We want a bunch of different, we want to be able to see the actual distribution. So let's clean this data up. Let's remove some of the noise by trimming a certain amount of unneeded variables. And then let's do the histogram again and see what that looks like. So we're going to do this only on the numeric variables. So we're going to do numeric is equal to data dot. This is a kind of a hidden command. So it's get numeric, and it'll just return all of the numeric variables. Sorry, I need the data. Which is a fun kind of little little trick so you get all 6 of the numeric variables that we created. And now that includes cylinders, correct? So this time, if we want to do this for all of them, we're going to import a couple different modules. So we're going to import modules. We're going to do from scipy import stats, and from numpy, we're just going to import numpy. Import numpy as np. Alright, so the best way I found to do this is, let's say we wanted, you'd probably want to do these individually. So you can do data, we'll just make a new data frame, outliers, and that's going to equal to data. We're going to take data.price, and we want data.price.quantile to be, in the 99.5th percentile, right? So it's less than whatever this value is. So anything over this on the high end is going to be too high for our use case here. We also want on the other end price to be greater than data.price.quantile than anything in the 0.005 range. And if we run this, we should get a data outlier set. So we shaved off 41-ish thousand rows here. And so that should really reduce the amount of huge outliers that we had. So let's take a look. We just did price. So let's do data.box plot, and then we'll do price again and see how this looks. So that, oh, sorry. It looks the exact same because we did data, not data outliers. Ooh, had me worried for a second. There you go. So we still have a lot of upended outliers, but this is the mean right here is around $10,000. We have, I believe the high end is the, this is basically a certain subsection. I believe it's like the 25th percentile to the 75th percentile. These upends are the 95th percentile, like of the outliers, and then these are anything above that area. So let's also look at the histogram of price again as well, just to see what that would look like. Because before, this is what it looked like before, right? So everything was right around the left side of the screen because we had such huge outliers. Now when we run it, it should look more like a normal distribution, or half of a normal distribution because we're starting at 0. So that's also something to consider. I'm not going to get too far into it in this video, but on Craigslist, it looks like a lot of people just put the price at 0 and did like a what's your best offer type of thing. That's something that we might want to remove all of those in the data set and get something that's more normally distributed, or we want to change how that's done, see what if they in the text they had some sort of pricing information, but it's something to watch out for, something to think about when you're evaluating this data set. Let's do the same thing for the outliers with not just price, with the odometer. So we're going to change the odometer here. We're going to change the odometer here. And we need to change it everywhere, I guess. And if you're going to be repeating this, whenever you have to do something more than once, I recommend writing a function. But for this use case, for essence of time, I'm not going to. So same thing, data.outliers.hist. Let's do box plot. And then we're going to do odometer. Perfect. So we should see something similar. Again, you have this box plot, which is pretty normal. No one's selling a negative car value, so we wouldn't expect to have too much downside deviation. But there is a good amount of outliers that are above that certain threshold up here. So Again, this is a great way to visualize and understand the data cleaning process, and this is how we can go about removing certain thresholds. So we could remove an even larger threshold. We could remove only a topside threshold by doing something like just this, but I think for this use case, this is the most effective process right now. So the last thing I want to talk about related to data cleaning is scaling your data. So for some algorithms, especially the ones that use Euclidean distance, like k-nearest neighbors, it's important to make all of your data on the same scale. So again, for something that uses distance, larger values can have larger distances, and that means that some features will be counted for more than others in the algorithm. So when we scale something, we put everything in the same numeric range. So a lot of the times you'll see like z-score scaling, where you make everything a z-score, or you'll have like some sort of mean differencing, which can give you a score between -1 and 1. And then you have min-max scalar and some other vector scaling techniques that'll give you a value between 0 and 1. I generally like values between 0 and 1. They're great for different types of analysis, for, again, k-nearest neighbors or doing some PCA stuff. So let's go through and show you how to do this. You don't generally need to scale your data with linear regression or with tree-based models or naive Bayes, but there are some specific types of models, even in deep learning, where actually scaling your data can improve speed and quality. So to get started with min-max scaling, we're going to use a different library than we have, and we're going to use sklearn. So we have to import that. So from sklearn, pre-processing, import min-max scalar, and we're going to do. So when you do this, you have to create a scalar object, and that is scalar. All right, so we fit the scalar object, and then we use the scalar object on our data set. So in order to fit this, we do scalar.fit, and we put in the data that we want to fit to it. So it's data, cylinders, and then so you have to do some, to get one frame fit, you have to do some idiosyncrasies to get it in the format that it's looking for. So we can either use NumPy to do this, or we can do kind of a workaround in Pandas. I'm going to do that since this video is mostly focused on Pandas. We do values, which creates an array. So data.cylinders is a series. If we do data.cylinders.values, it becomes an array. And we have to reshape this array so it's an array of arrays. So we do -1 at 1, and let's look how this looks now. So it seems like a lot of hoops to go through, but now you can see this is an array of each of these individual arrays that we have. That's just the way that this feature scaling module accepts the data in. So we have now fit this, and we do scalar transform, and then we copy this same information in. So as you can see, previously we're looking 4, 6, and then this is the average number of cylinders. We should be getting things all now between 0 and 1. So same thing, now we have 1s, and these are all scaled individually. So we can also skip the fit and transform set, and we can just do scalar fit underscore transform and include the same stuff, and we'll get the exact same results. But generally, how sklearn works is you fit a model, and then when you want to find the output from a new input, you use this transform feature, and that's how they have built out all of their regression, all of their machine learning, any of these other algorithms that they use there. So after you've scaled this, you can scale all of your numeric data or just some of it, again, depending on the type of analysis that you're hoping to run. I think that's it for data cleaning today. Again, thank you so much for watching. If you have any questions about this, please leave them in the comment section below. Good luck on your data science journey, and please look forward to more videos like this from me.